have done so far. So in operating systems, we know that it's a type of system software. In O levels also, we have looked at it under the software. You can have system software and application software, and under system software, you have operating systems. So that's a main component, right? So operating system is a system software that manages computer hardware, software resources, and provide common services for computer programs. So without operating system, it will be bit difficult to manage the hardware and also necessary resources for computer programs. So today, under evolution, we will discuss how operating systems were evolved, right? If you look at the examples, there are many types of operating systems are available, but most common one we call Windows operating system. And this is exactly what we were, we will be using. So there are different versions available. Now, if you take Windows, the latest version of Windows is called Windows version 10. And then there are like many others. So it started with 1, that means Windows version 1, and now we are in Windows version 10. So likewise, most popular operating systems in Windows is Windows 10, Windows 8.1, Windows 7, Windows XP, Windows 2000, Windows 98, and Windows 3.1, and so on. Right. And then if when it comes to technical people, most of the time they prefer to have what we call Linux operating systems, which are free and open source, right? Whereas Windows is commercial, that means you have to pay for it, and it's proprietary, meaning like you don't know like how they have written the code. It's not available for the general public. Similar to Windows, when we talk about the Apple computers, we have what we call Macintosh operating system. So in short, we say Mac OS. And then if you take mobiles, for example, most popular operating system is Android operating system. So that's actually Google's operating systems. Google actually, created this based on Linux kernel. Right. So that's the introduction. And then when you talk about the operating system, there are two parts. We have to talk about the kernel as well as shell. Basically, kernel is the core. Remember, I told you, like when you talk about the Linux, we talk about the Linux kernel, right? That is known as the core of the operating system. So which is actually used to control main memory, processor, secondary storages, and the hardware stuff, right? So that's actually done by the kernel. And then you have a shell to interact with the user. So it's a computer program, works as an interface to access services provided by the operating system. So mainly users can interact the hardware stuff through the shell. So if you briefly discuss what services provided by the operating system, the first one, program execution. For example, when we execute something, let's say you're adding, two numbers. So first of all, you have to get the input, process, and the output. So you'll be have a, when it comes to getting input, you have to first of all store in a memory. So memory allocation should be done. Then you have to perform the calculation, that means addition. Then you have to store the result, right? So all these different steps comes under execution. So that's one of the main services provided by the operating systems. Then the second one is you have to interact with the what we call the peripheral devices. We know that in the computer there are many devices you connect to the computer, like starting from keyboard and mouse. You can connect printers, cameras. I mean various different types of devices. So they are known as input and output devices, and you know that usually these devices are slower than the processing power of CPU. So because of that, you have to match these speed. So because of that, you need the services operating systems to get in data from these peripheral devices and sometimes output the results into peripheral devices. Then the third one we call file management. File management meaning like when you want to permanently store something in the computer, we can put it as a file. So these files are need to manage in the secondary storage. So creating a file and you allocate space for those files. You are sorting the files. You create folders, you can copy paste, like everything has to be done within file management. So that is another service of operating system. Then communication, especially I told you, like when it comes to different devices, so you have to communicate between among the devices, as well as sometimes you have to communicate with the software systems as well. Then resource allocation, when you want to execute something, you have to allocate memories, you have to allocate the space, you have to allocate the time of the processor. Resource allocation, again, very very important. Next, error handling. So when you work with the computer, especially hardware, so there might be errors, especially when you're getting data from outside, right? You have to make sure that there's no errors in the data. If so, so sometimes we can work on error correcting, codes, or maybe you can request the data again. So there should be a way to handle errors. Again, another service of operating system. Provide protection facilities, especially in operating system. We have to provide, different facilities to protect the data. Right. The next thing we discuss is actually the booting process. You know that when you press the start button of a computer, that means when you power is on, you know that computer starts. The very first thing what happens, it will check whether all the hardware devices connect to the system is properly operating, right? So that's the very first part, and then once it's done, it's load the small set of instruction you need for the basic input output, and then it will hand over the system to a operating system. So usually when you switch on the computer, usually you see the main screen, black and white screen with some characters in it, so like this. So let me show you an image where when we open up a computer, so usually you see this screen, right? Yes, so this is the main screen sometimes what we will see. So what happens, this is called BIOS, basic input output system, which actually check whether all the devices are working, and then only it operating on the operating system, right? So in booting process, system checks all hardware and software installed for running a system, and it load into memory. The power on self test, we call pause, happen each time after turn on the computer. It is diagnosis test sequence for all hardware devices. In case if there are failures in any of the devices, it will make different beeps. Now, once you do that, it will go to what we call the master boot record. This is the place where everything is stored. Now, for example, which operating systems you use. Now, we discussed earlier that sometimes you can install multiple operating systems in a computer. Right. So that's what we discussed last time. And we have stopped where we have evolution of operating system. So let's start with this one. So there are four phases we are going to discuss. Let's start with the non-availability of operating system. So that means early days, there was no operating systems. Right. So let's take down. When you finish it, let me know about in the chat. Say okay. So I know that you have finished. When you take down, type in the chat, you're okay. So I know to proceed.
Okay, sir.
Okay then. So let's take down the first one. So this is during around like 1940s to 50s. Das nam si hataliya panha atara tamai kewe. So nowadays we have something called Windows, but those times there were no operating systems, which means somebody has to do it, right? If operating system means what, remember we talk about sharing resources or allocating resources, like put it into memory and so on. So somebody has to do, which means a human has to operate. So the human, that means the person operates whatever called the jobs. That means when you want to execute a program, somebody has to schedule this, and then you have to, that particular person has to look for the resources, right? And those days we didn't have monitors as such. We had some lights, if you remember. If you take ENIAC, for example, the very first dual general purpose computer is called ENIAC. There we have what we call the lights, right? Now, for example, let me show you a picture of this. The output. So if you remember the ENIAC, what they had was uh, you know vacuum tubes. They were used as electronic technology, and the display is a set of bulbs. You had a set of bulbs, uh, which output the results. I'm actually looking for a figure just to show you how this was done. Right, let me show you a video. So let me change the share. So in this one, what you see is the ENIAC computer, the output, the set of bulbs. Put that a pin on.
Pena, sir.
Right. So this is the ENIAC and this is the outputs. We didn't have a monitor. We had set of bulbs. So the answers were output using these set of bulbs. Right. So likewise. So the bulb lit like this, right? To output a number. If you remember in ENIAC, we perform calculations. Those calculations are output in as numbers, right? Okay, let's move on to the text again. So here is like, so in ENIAC we had this. So outputs, you have an array of bulbs like this. Right. So then I told you like there were no operating systems during this time. So human has to do everything, and the displays were light and the switches. You have to use punch cards. Have you seen punch cards? Pota punch card da kaltina? Nimesha?
කියන්න දන්න.
Huh? Have you
දැකලා
seen?
තියෙනවත් දන්නේ.
Done. All right. Okay. Uh, Let me show you punch card as well. This is output I told you. So the input, there was no keyboard as such earlier. So what you had is punch cards. So this is output and this is input. Input like a card. We call a punch card earlier. Have you seen this earlier?
No.
Okay. So this was the input. So you have a, this in one card you have one instruction. එක instruction එක පොතේ මේකේ තියෙන්න පුළුවන්. Right? So this is so the punch card. So I told you the outputs are bulbs, and those days inputs were the punch cards. So it was like this. So the output is, you have a set of bulbs, and input is like a punch cards, right? So that's how they were, put it. And then if there's a problem, um, you know, if there's an error or bug in the program, then it's halted, and then lights indicates there's an error, right? I told you that we had lights, right? So if it is success, then it will output the results. Sometimes there were printers as well, right? One of the problems those days is you cannot make use of processor, because if when humans are involved, it takes time you to input the data into the computer. So there's a lot of time it takes to manually work with a human, right? um, okay, shall we take down one at a time what has happened? So this was during 1940s. 1940s to 19 mid 1950s, there was no operating 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 systems installed in machines, in computers. For example, um, the output was uh, indicated using bulbs or printouts. The input was punch cards. Therefore, human assistance, human was involved in many things. First one is scheduling jobs, which means what programs you are going to carry out and so on. Supervision of resources like the memory, like the uh, storage and things like that. Programmer has to check, register details and main memory to determine any errors. One of the main issues was inability to use processor utility. Inability to use maximum the processor utility. පුතා ඉවරුනහම මට කියන්න ඉවරයි කියලා.
How is it?
Right. So there are some characteristics. අපි මේ කාලේ තිබ ඔපරේටින් සිස්ටම් ත විශේෂ ලක්ෂණ තිබුණා. Characteristics. Yes. Let me put in a point form. They were done serial processing, right? Serial processing means the programs were processed one after the other. දැන් ගත්තහම් පොතේ අපිට එක සැරේ වැඩ කීපයක් කරන්න පුළුවන්. Early days there was not like that. It was basically serial processing. You execute one program and then you go to the another. So others has to wait basically. So this is called serial processing. And it was a single user systems. Single user means one person can use the computer at a time. Right now, if you take a server, millions of users can access the same machine. So users should have a good knowledge in hardware stuff. Right. So these are the some of the features. So remember that we discussed in the very early days there was no operating systems. We have used lights. We have used punch cards, and you can run only one program at a time, serial programming, one after the other. You have a single user system where only one person can use a computer given time, and users has to directly interact with the hardware. So if there's a problem, so you have to directly attend to it. And then the user should also have a good knowledge in hardware. And right now we don't have to worry about this nowadays. අපිට මේ දවස්වල නම් පොතේ hard එක මේ keyboard mouse මේවා ගැන හිතන්නවත් දෙයක් නෑ. But early days it was not like that. Last one. හරිද පොතේ? ලියගෙන ඉවර නම් කියන්න.
සර් තේන්නේ නෑ.
නේ සොරි. කොතනද අන්තිමට පුතා ලියලා තියෙන්නේ?
කැරක්ටරිස්ටික් වල තුන්වෙනි එක ලිව්වා.
අප්පච්චි මම මේ අනිත් පැත්තට ඇවිල්ලා හරි පොතේ. හරිනේ දැන් පේනවනේ?
ඔව් පේනවා සර්.
හරි. Sorry, Puthe.
Hi, sir.
Major problem was users have no interaction once the job was submitted. Kota iwarna kiana.
Hi, sir.
Right. So the next one, let's write down simple batch processing. This is non-availability of operating systems. So this is the sub. Then simple batch processing. Right. This is during 1950s and mid 1950s. Then Kalingikedi, what has happened? Only one job at a time. එක ජොබ් එකයිනේ නේද මං කිව්වේ එක වැඩසටහනක් තමයි අපි දුන්නේ ඊට පස්සේ කිවරුනහම තමයි ඊළඟ එක. So here uh, so they have improved this by having a set of jobs. අපි කියනවා batch කියන්නේ batch එකක් කියන්නේ කොට කීපයක්, right? And you had the monitors nowadays. So by that time we had monitors, and then it's again the same like earlier. You users should have the good knowledge about the computer system or especially hardware. Now processor utilization was increased, which means you are submitting multiple jobs at a time. Um, so the programs usually, as I told you earlier, stored in magnetic tapes, and then you take main memory as a batch operating system, and then it put it into memory. So the output again will be printed out or saved in a tape, right? So that's how they were working. When you look at the features or the characteristics, again one program at a time, that means single program. um, so there's no way that you can join like in earlier when you submit the program. Again it was uh, there was a lot of time it takes to execute, we call higher response time. Again, no direct access to hardware, and also processor is idle input output, so nothing will happen during when you enter data and output, right? So that's um use of the monitors that handle, right? Okay. So okay, let's take down the details. So this is called simple batch processing. Uh, um, so not like in earlier, we were putting into groups. Earlier, we put only one task at a time, one job at a time. Job එකක් කියලා කියන්නේ, it's a execution of a program, right? So that's we call job. So you can put multiple jobs at a time, right? 1950s to mid 1960s වලට වගේ තමයි අපි මේක ගණන් ගන්නේ. Right. So let's write down. So these days we had, I told you the monitors were used. Um, so let's write down. So this is during mid 1950s to 19 again mid 1960s. Batch processing systems were used, right? So batch processing means, as I told you earlier, so you can have multiple what do you call multiple jobs at a time. Right. No direct access. No, earlier it's direct access. So during this time, user had no direct access to the machine, which means the hardware, right? Um, um, a group of uh, jobs we call batch. Uh, uh, Group of jobs placed on the input device. So it's batch processing basically. I told you like batch means you have multiple several that executed sequentially one after the other anyway, but one time it saves some time in the input. So let's write down the characteristics. These are the features of these days. First of all, data were stored in magnetic tapes, and the output is saved in magnetic tapes, not tables, but it should be tapes, and the output saved in magnetic tapes and, through printouts. So that's about the input and output. The batch processing the batch processing submission of multiple programs jobs together, but still um, one program at a time. Execution happens. Happens with, it should be execution happens with one. අපි වැඩසටහන් කීපයක් එකට දෙන්න පුළුවන් ඉන්පුට් කරන්න පුළුවන්, but still it will execute one program at a time. No direct access, I already told you. No direct access because nowadays you are using a monitor, so no. Right, no direct access. Processor, one of the issues was processor is in idle without any work during input and output. So again, there are some issues. Again, things like, the program has to wait. Idle means processor, there's a time without any work. We call idle when you input and output data, right? So that's the second one. We call it batch processing systems. Okay, next move on to the next one. We have 31. We call multi-program batch system. It should be a single word, actually, multi-program batch system. So the third one, multi-program batch system. So what happens in multi-program? Now, there's a time wastage. Remember in the previous one we discussed, whenever the program waits for input output, nothing will happen. අපි වැඩසටහනකට ඉන්පුට් එකක් output එකක් වුණාම යා wait වෙලා ඉන්නවා කියලා කිව්වා. මොකද එකයි run වෙන්න පුළුවන්. So during this one, what happens? You can start another program, right? So this will reduce the time, right? So let me give you a small picture to explain this one. Now, so in this particular case, let me crop this. So this is the problem, right? Earlier, if you think about only one program at a time, so it will run and it waits sometimes because waiting is for the input and output. Now, multi-programs means you can run multiple programs. Now, when the program A waits that period, program B starts, right? When program A run and wait for input and output, during that time, program B can start. So the beauty is when you combine it, right? So you don't have to wait like earlier. Earlier waiting time is longer because when you're combining, the waiting time being very small. So this is called multi-programming. පොතේ මේක ඇඳගෙන ඉවරලා මට කියන්න.
Hanisha.
Okay පුතේ. multi-programming කියන එක තේරුණාද? දැන් මේ දක්වා කලින් ඒවල දෙකත් වැඩ කර එක ප්‍රෝග්‍රෑම් එකක්. පළවෙනියේදී එක ප්‍රෝග්‍රෑම් එකක් විතරයි අපිට දෙන්න පුළුවන්. දෙවෙනි එකේදී අපිට ප්‍රෝග්‍රෑම් ගොඩක් එක සැරේ දෙන්න පුළුවන්. හැබැයි ඒත් රන් වෙන එක ප්‍රෝග්‍රෑම් එකයි. මේ තුන්වෙනි වර්ගයේදී ප්‍රෝග්‍රෑම් ගොඩක් අපිට රන් කරන්න පුළුවන් එක ප්‍රෝග්‍රෑම් එකක් නැවතිලා ඉද්දී. They wait for input and output. I told you process in idle state. So during that time another program can start. And this is called multi-programming. අපි features කියලා දාමු characteristics. you can say multiple jobs at once. One job could use the processor while other jobs busy with input output. Memory is segmented, store several programs. කලින් memory එකට load කරපොත් එක program එක සැරයකට. Now you have to store multiple programs. So that means you have to divide the memory. We call segment the memory. So multi-program batch systems, the memory is divided. So memory is segmented to store several programs because you can now run multiple programs. Right. So that's about the multi-programs one. Let's move to the next one, time sharing system. So you could share the time between this. මට කලින්ග කියන්න බැරම් පොතේ එක උනේ mid mid 60s to 1980s. So the time duration. මට මේකෙදි කියන්න බැරුණා පොතේ පැත්තක ලියාගන්න. This is during mid 1960s to 1980s. Multi-programming concept was used. So likewise, time sharing is what we have. So this is during 1980s to present day. So that during 1980s to today, to present day, time sharing was used. Okay, users introduces to minimize response time and maximize user interaction during program execution. Program में run करने को डपोते में time एक processor time could be shared. So the feature characteristics. So it's like earlier, it's multi-programming is used. Multi-programming is used to handle multiple jobs. It's like earlier. Processor time is shared among multiple people. Early it was single user, right? Early it was single user, multi programs. Now we have multi user, multi programs. So that means multiple users can access the system simultaneously. හරිද පුතේ?
හරි සර්.
right. හොඳයි පුතේ. මෙන්න මේ ටික තමයි මතක තියාගන්න චූටි දෙයයි තියෙන්නේ. There are different operating systems evolution. Early days we didn't have any operating system. That's the first one. So user has to directly manage the resources, and this was difficult. So then we have a simple batch system where one program could be run. And then we have multiple programs, and then when the processor stops for input, then another program can take over. So multiple programs run at the same time. Last one, time sharing. Even multiple users can access the system interactively. So that this is exactly what you need to remember. Right. So let's move the next subtopic. We discuss what operating system is. We discuss what are the evolution of the operating systems. Next, I would like to discuss main functions. So let's take down main functions of operating system. So there are a couple of functionalities available. Let's first of all list down the functions, the main functions. First of all, we talk about the processors, process management. Then you have memories. Then we have device. Then we have file. Finally, we have what we call the security management. And provide interface. Right. So let's start with the first one. Right. So let's start with the first one. This is just to discuss. We'll start with process management. So we'll work on the process management. So when we talk about processes, what is a process? Onimisha, what do you mean by the process? Opute, what do you mean by a process? A process is a set of instructions, isn't it? So when you execute it, it will create a process. Now, for example, when you read a file, save data, printing a document, right? Open a browser. So all these activities actually created a process. So we need a mechanism to manage all these processes. So we have in operating system, we have process management. So we can say a process is a set of instruction and execution. Whenever you have something to execute, you have processes, and then you have multiple processes. However, given one time, only one processor operates in the CPU. Therefore, all the processors are activated one at a time in a selected order. So sometimes you have to prioritize, isn't it? Some operations are more important than the others. Okay, so that's about the project management. The memory management. When multiple tasks are in the main memory, should be allocated without any collision, without any problems, without any issues. You have to manage the memory because multiple tasks. Further, input instruction and data to CPU and output information from CPU are also kept in the memory. When a task is completed, OS should release memory for another task. So for example, let's say we are going to open two programs, Word and Excel together. අපි හිතමු අපි Word Excel දෙකම වැඩ කරනවා කියලා. Now when we have this situation, so multiple programs, when you're running multiple programs, you have to allocate memory for the programs, let's say Word and Excel. So when you allocate memory for Word and Excel, you have to allocate separate places in the memory, isn't it? We should not make any clashes. You may lose the data. However, when let's say you finish working with the Word, then you have to free the operating system, right? Because you have to release the memory. Right, so that's about the memory management. Then device management. පොතේ ලියලිවරණ කියන්න. හරිද
Hi,
පුතේ?
sir.
හරි හරි පුතේ. And devices කියලා කියන්නේ පුතේ අපි දන්නවා එක එක අපි devices සම්බන්ධ කරනවා. We put various devices connect to the system like printers, scanners and so on. අපි ඒකට පොදුවේ නමක් කියන, what do you call it? The common name for the devices which connects to the computer? A printer, scanner, even keyboard, mouses. We commonly call them as, yes, peripheral devices. What is it? Opote?
Peri-
Peripheral
Peripheral
devices.
devices.
Yes. When we have devices which connect to computers, we usually call them peripheral devices. Right? Now the problem is when there are like many devices connect to the computer, their speeds are different. That means data transfer rates are different. So you have to data transfer should be matched, isn't it? Right? For example, where the direction of the information flow. Now, when you're typing something, it's in, right? You are inputting some data. When you're taking a printout, you are getting out, right? So all these directions, everything should be handled by the operating system. ඊළඟට පොතේ දැන් සමහර වෙලාවට මේ devices, peripheral devices, when you take the peripheral devices, uh, you have to install the relevant device driver. ඒ කියන්නේ අපි printer එකක් ගත්තොත් ඒකට අදාළ software එක නැතුව, drive එක නැතුව අපිට ක්‍රියාත්මක කරන්න බෑ. So we need to install what we call device drivers. Some you don't have to install anything. We call it plug and play, right? So let's take down this operating system manages various peripheral devices like printer, scanner. There are many others. It considers factors such as speed of the devices, amount of information to be transferred, its purpose, direction of where information flows, and protocol used to transmit information. To work with device, relevant device to work with the device. I told you the relevant software needs to be installed. The software is called device driver. Should be installed. However, some devices work once they are connected. Once they are connected. These devices are known as plug and play devices. So this is called device management. Talili warna mata kiyan.
හරි සර්.
හරි පුතේ. තව දෙකක් තියෙනවා අපි එහෙනම් පුතේ කළා අපි සතියේට කතා කරමු. මේවා තියරි පුතේ අතරම කියනවා මේකේ තව තියෙන ගොඩක් අපිට තියරි කතා කරන හැබැයි ටිකෙන් ටික තේරුම් අරගෙන යමු මම ලබන සතියේ ප්‍රශ්න ටිකක් මේකට අදාළව දෙන්නම් මේ දක්වා අපි කතා කරපු ටිකට පුතා එහෙනම් ඒ ටික බලලා ඉන්න ඕනේ කෙටියෙන් මතක් කරොත් අපි අද දවසේ කතා කරේ evolution of operating systems කියන එක යටතේ අපි කතා කරා non availability of operating systems simple batch system, multi-program batch system, and time sharing systems. And then we switch into main functions of operating system. We discuss 3: process management, memory management, and device management.